Good evening, students. Today we will start the chapter P block elements. So this is in front of you the periodic table in which S block is present. This is the middle portion, that is a D block. The rightmost corner is the P block and the bottommost is the F block. So the whole periodic table is divided into 4 blocks as such, and the elements are placed in accordance with their atomic number. So this is the P block which we are going to study now. As you know that in a periodic table, the horizontal placement of the elements are known to be as periods, and the rows, okay, the columns are known to be the groups. Okay, so again one more important question arises here, that why this set of elements is known as the P block. The answer to this question is that if you try to arrange the electrons of these elements, the last electron or the valence electron will enter the p orbital. So it is also given as 2p, 3p. 2p means what? All these elements that you can see, boron, carbon, nitrogen, oxygen, etc., the last electron of these elements will enter the 2p orbital. For this aluminum, silicon, phosphorus, this will enter the 3p. Similarly 4p, 5p, 6p and up to 7p you can observe. Therefore, P block element is also classified as group 13, 14, 15, 16, 17 and 18. So this thing you have to remember. In class 11 now we are going to study about group 13 and 14, and in class 12 the rest of the portion, that is 15, 16, 17 and 18 is present. First we are going to study about the group 13 elements, and in group 13 what are the elements present? That is boron, aluminum, gallium, indium and thallium. So you can see the abbreviations of these elements as well. And also the atomic number of boron is 5, aluminum is 13, gallium is 31 and indium is 49, thallium is 81. So 5, 13, 31, 49 and 81. Okay, now you see here, you know that this is group 13 elements, right? We are moving down the group. Okay, after boron, at the means below boron, aluminum is present. So we are moving in this direction. We are studying about the group 13 elements. Now don't get confused, this is just a table. It is not organized as in the periodic table. In the periodic table you will get boron, aluminum, gallium, indium. Here it is just arranged in tabular form. Now boron was having 2p, right? So the atomic number of boron is 5, so it is placed. Helium is known to be as 1s2. So instead of writing 1s2, you can also write within bracket helium. That designates that the atomic number of helium plus 2s2, 2p1 is present. So total 2 plus 2, 4 plus 1, 5. So 5 electrons are there. As you observe here, it is 2p1. So as you can see that 2p1, the last electron is entering the p orbital, 2p orbital. Okay, and for aluminum is entering the 3p orbital. So for 4p orbital for gallium, and it goes on up to 6. So if you observe again here, you can see that the number of shells is increasing, the number of orbitals is increasing in one case. First of all it was 2p, then next it is becoming like 3s, then it is 3p. Okay, so the number of electrons is increasing as well as the number of shells is also increasing. One important point you have to remember here, that when we move down a group, the number of orbitals, the number of shells always increases. Therefore their size is also increasing. Okay, and enthalpy is decreasing. We have discussed in details about this in the last class. Then when we move along a period in the periodic table, what happens? The in the 2p only, the number of electrons will go on entering. So the number of shells is not increasing there, but the number of electrons are increasing. Clear? So the size is decreasing as we move along the period. But if we go down the group, the size always increases. The question might be, what is the electronic configuration of the group 13 elements, or you can say group p block elements. If it is saying p block elements, then it will be ns2. okay, n stands for 2, 3, 4, 5, whatever orbital we get. Now p1 to 6, why it is given 1 to 6? Because if we talk about the whole periodic table, p orbitals can have maximum 6 electrons, and if it is in one case like 2p1, the second electron will be 2p2, 2p3, 2p4, like that, 3p1, 3p2, 3p3, like that up to 3p6. So any p orbital, whether it is 2p, 3p, 4p, it can have maximum 6 electrons. Clear? Except for helium, because you know that helium is having 2 electrons, so it will be only 1s2. We need not go to the p orbital, so the configuration of helium is an exception in this case. The non-metallic character of elements decreases down the group. So when we move down the group, what happens? The non-metallic character decreases, means as we move down the group, you will get elements which is having more of the metallic character. The above elements, the elements that are above, is having more like non-metallic character, covalent character, and down the group, if you move on, you will get more metals. okay, now if we specify what is the electronic configuration of group 13 elements, then the answer will be ns2 np1. okay, in group 13 all will be np1, because we have already seen that the boron is 2p1, then carbon is 2p2, like that. okay, 2p1, 3p1, like that. So for the electronic configuration of group 13 elements, it is ns2 np1. Now the group 14 elements. okay, you have to imagine here again that the atoms are arranged like this in a group, not in a period. This is just a description, that is why it is represented in tabular form, but this is not the periodic table. Remember, carbon, silicon, germanium, tin and lead as in the periodic table. okay, so you can see here carbon is having helium, that is your 2 electrons is there, or you can write 1s2, no problem. So helium is 2 plus 2, okay, 2 electrons are there, again here 2 is there, so 2 plus 2 plus 2, 6 electrons of carbon. So like this, if you go on arranging for silicon, germanium, you can see it is 3p2, 2p2, 3p2, then 4p2. So you can say np2, right? In general you can say np2. So the electronic configuration of group 15 element is what? ns2 np2. Clear? The first ionization enthalpy of group 14 members is higher than the corresponding members of group 13. So if you compare this group 13 and group 14, the elements that are present here will have less ionization enthalpy as compared to the elements present alongside in the group 14. Why this happens? Because you see, when we were in group 13, what happened for boron? It was just 2p1, right? For carbon, now it is 2p2. So the electrons are entering in the same orbital. In 2p orbitals only they are entering, right? So the number of charges is increasing. Hence it is difficult for us to remove those electrons from the same shell. But if we move down the group, if we talk down the group, what happens? Once it is 2p, then it is 3p, again it is 4p. So number of like orbitals is increasing, so the electrons are moving far away from the nucleus, and since nucleus is positive, electrons are negative, they will attract each other with less capacity. okay, because they are moving away from far away from each other, so there is less attraction between them. But if it is added, like in 2p only electrons are being added, then what happens? The charges are increasing, their capacity to attract remains constant, or it is increasing always. So the ionization enthalpy will also increase because it is now difficult to remove the electrons from the orbitals. Okay, high amount of energy will be required, and therefore ionization enthalpy also seems to be high.